In this video, we will learn how to add or subtract matrices. To add or subtract matrices, first you have to check a condition that order of the matrices should be equal, should be same. Means you can add two matrices A and B if their orders are same. Means if order of matrix A is 2 by 1, then order of matrix B must be 2 by 1, and as a resultant matrix also you will get the matrix C which has the same order. It's very important to check orders of matrices before we start their addition. Similarly, for subtraction also, you can subtract the matrices if their orders are same. Let's say order of matrix M is 2 by 2, then you can subtract matrix N only and only if the order of matrix N is 2 by 2. Here also, as a resultant, whatever matrix you get, the order of that matrix will also be 2 by 2. So this is very important to understand before we go ahead with the addition or subtraction of the matrices. Now here let's see how to add two matrices. So let me take a question that matrix A is equals to 5, 6, -3, 2, and matrix B is equals to 1, 5, 7, 2. These are random matrices we have taken. So when I have to calculate A plus B, I have to check the order of these matrices. Here you can check the order of matrix A is 2 by 2. I quickly revise that how can we check the matrix order. So here you can see this is row number 1 and this is row number 2. So we have two rows. So this first number represents the number of rows. Similarly, here this is column 1 and this is column 2. So this two columns are there. So this second number represents number of columns. So you can say that we have order of matrix A as 2 by 2. Similarly, in matrix B also we have order of matrix B as 2 by 2. Now as I want to perform A plus B, I will write the matrix A first, 5, 6, -3, 2, plus order of matrix B is 1, 5, 7, 2. Now the real performance of the solution of matrices will happen. So you can see what we have to do. We have to add corresponding elements. Now what are the corresponding elements? So you can see here this 5. What is the position of this 5 in matrix A? So I should say it is A 1 1. What is 1 1 means? It is the position of this 5 is in the first row and first column. Similarly, can you tell me what will be the first row first column element in this matrix B? Yes, you are right. It is 1 because this is called B1 1. So I should add these corresponding numbers, means I should add 5 plus 1. Similarly, if I go ahead, you can check this 6 is A1 2. It is in the place of first row second column. Which element do you find in the column B in the first row and second column? Yes, it is 5. It is B. You can see this, it is in the first row and in the second column. So it is called B1 2. So here I have to add A1 2 with the V12. This is called corresponding. So correspondingly, we have added the numbers. Now you can check your own. -3 plus 7. Similarly, for the fourth element, it will be 2 plus 2. So this is the addition. Now, if I add them, so 5 plus 1 is 6, 6 plus 5 is 11, minus 3 plus 7, which is 4, and 2 plus 2 is also 4. So this is my resultant matrix. This is my resultant matrix. So you can also check this order of this resultant matrix. It is also 2 by 2. You can see there are 2 rows and 2 columns. So you can check this condition that this order of matrix A is 2 by 2, order of matrix B is also 2 by 2, and hence the resultant matrix of A plus B is also 2 by 2. Okay. Now let me perform the same thing for subtraction, right? So we will use subtraction now. Let me discuss this. The procedure for subtraction is also same. First, we will write the matrix A 5, 6, minus 3, 2, subtract 1, 5, 7, and 2, and we will subtract them. So you can see 5 minus 1. You can understand the correspondingness now. We are subtracting the corresponding elements. 5 minus 1, then 6 minus 5. Yes, you all can talk with me. Minus 3, minus 7, and last we have 2 minus 2. So when we subtract this, you can see this. What is the resultant matrix now? 5 minus 1, which is 4. 6 minus 5, we have 1. Minus 3 and minus 7, we have minus 10. And 2 minus 2 is 0. So this is your resultant matrix of A minus B. Hope you have understood this. Let's have one more question where we have to check certain rules for the addition or subtraction of matrices. Let's say we have 3 matrices, 1, 5, 3, 2. Matrix B is 3, minus 7, 2, 0. And we have matrix C also, where we value this matrix C is 5, 3, minus 2, 7. Okay. So let's say we have to verify that whether this A plus B plus C is equals to A plus B plus C. This kind of questions can be asked in your board examinations, and these are very common. Now here you can see that this A plus B. So here how we will see. First we will focus on the left hand side of the matrix of the equation, where we can see this A plus B in the bracket. So we know the board mass rule. So first we will calculate A plus B. A plus B is equals to, we know this method, 1, 5, 3, 2 plus matrix B is 3, minus 7, 2, let me use this eraser here. Just a minute. Let me erase this entire portion. Yes. Okay, let's go ahead. So we have, again we write matrix A, which is 1, 5, 3, 2 plus 3, minus 7, 2, and 0. So when I add this both, now you understand, and if you are okay with it, you can write this answer directly. I am adding this corresponding numbers 1 and 3. So what is the answer? Yes, answer is 4. I can write it directly without putting that extra step in between. Similarly, 5 plus minus 7 is minus 2. 3 plus 2 is 5, and 2 plus 0 is 2. So this is my resultant matrix of A plus B. Now I will calculate A plus B plus C. So for that, I have to write this resultant matrix of A plus B. So what is my A plus B? So I can see from here the A plus B is 4 minus 2, 5 and 2 plus matrix C, which is 5, 3 minus 2, 7. So yes, you can see here when I do addition, the corresponding numbers you can understand. It is 4 plus 5, so it is 9, minus 2 plus 3, so it is plus 1, 5 plus minus 2, so it is 3, 2 plus 7, which is 9. So this is my resultant matrix of this entire LHS. So let me call it result number 1. We will come to this point again, that result number 1 is here, and then we will solve result number 2 also, and we will compare with it, right? Okay, so let's go ahead with result number this 2. So now let me go to the next place, or let me go to the next page first, and let me use this. Let me copy this ABC part. Yes, it is there on the new page. Let me check that previous page also it is there or not. Yes, it is there. It is here on the next page also. This will be good for me to write here. Yeah. Okay, so let's go ahead. Now we focus on the right hand side part. There we have B plus C in the bracket. So we will first calculate B plus C. So matrix B is 3 minus 7, 2 and 0 plus 5, 3 minus 2 and 7. So here we have the resultant matrix. To save the place, let me write here on the right hand side itself. You can definitely write this below this is equal to sign. Do not write in a single line, but because of space constraint, I am writing here. So you can see here 3 plus 5, so 8. Minus 7 plus 3 is minus 4. 2 plus minus 2 will give me 0, and 0 plus 7 will give me 7. This is called addition of corresponding numbers which we are doing. Now let's calculate A plus B plus C. So here I have to write this matrix A first, 1, 5, 3 and 2 plus the resultant matrix B plus C. So I cannot write B plus C, but I have to write this resultant matrix of B plus C, which is 8, minus 4, 0 and 7. So let me write the addition of it. 1 plus 8 is 9, 5 plus minus 4 is plus 1, 3 plus 0 which is 3, 2 plus 7 is 9. So this is entire calculation of my right hand side part, A plus B plus C. Let me put it result number 2. Now here on the first part, on the left hand side we have got the result number 1, which is representing A plus B plus C. So here we see the number 9, 1, 3, 9, and when we see the right hand side which we have calculated, there also our result is 9, 1, 3 and 9. So from our results 1 and 2, we can conclude that A plus B plus C is equals to A plus B plus C. So this way you can verify the given result. Now you should also know that this property is called associative property. You have learned in your 5th standard that this is called associative property. Definitely you have done it with the numbers, but here it is with the matrices. So instead of giving you this result, there can be a question that verify associative property property of matrices for A, B, and C. Here matrices can be given. So you have to check A plus B plus C is equals to A plus B plus C, right? Or instead of this, you can also prove this. It's okay if you prove A plus C plus B. That is also correct because it is also associative property, and if you verify, you will also be able to get the same result. Similarly, instead of associative property, they can ask you commutative property. So they don't give you questions directly, but they ask you, they give you two matrices, let's say A and B, and asking you to prove commutative property. So if you don't know what is commutative property, even though you know addition of the matrices, you will not able to score those marks, right? So I tell you the commutative property is A plus B is equals to B plus A. Huh? With numbers you have heard it many a time, like 2 plus 3 is equals to 3 plus 2, right? But the same way you have to prove or the verify for the given matrices. So how to add? You already know. You have to check A plus B. You have to calculate B plus A, and then the results will same. So you can say it is resultant matrix. They are equal. So they are following commutative property. Let's see some sums for subtractions as well. So let me take one question. A equals to 5, 3, 2, 0. These are random numbers I am taking. B equals to -3, 5, 2, 6. And if I have to subtract them, A minus B, or let's say the question is verify commutative property for subtraction. So commutative property for subtraction means you have to verify that whether A minus B is equals to B minus A is there or not. So some of the students, those who have already done this chapter, may conclude that this is not equal. But please, 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 whenever this kind of questions are asked, please check and then only conclude, because we can adjust some numbers in such a way that in some particular case A minus B can be B minus A, right? So we have to be cautious about it. Do not jump to the conclusion without any calculation. So first of all, we calculate A minus B. 5, 3, 2, 0 minus 3, 5, 2, 6. And now if I subtract it, so the corresponding numbers will be subtracted. So it will be 5 minus -3, which is actually 5 plus 3. So that is 8 plus 8. 3 minus 5, so it will give me -2. 2 minus 2 will give me 0, and 0 minus 6 will give me -6. So this is my resultant matrix of A minus B, which is the left hand side of the equation. So I will call it result number 1. Similarly, let me calculate B minus A. So in B minus A, -3, 5, 2, 6 is equals to, sorry, is minus 5, 3, 2, 0. And here you can see it is -3 minus 5 will give me -8. 5 minus 3 will give me +2. 2 minus 2 will give me 0. And 6 minus 0 will give me +6. So here this is my result number 2. So you can compare this result, see what it is. So here I can easily say from result number 1 and 2, we can conclude that A minus B is not equals to B minus A, right? So this way you can verify different laws of matrices for addition and subtraction. Hope you have understood this question. I will put few questions in our next slide of our solution, where you can find out more examples and practice sums as well. So thank you. Here we conclude. If you have any doubt